Hello guys, welcome on Tesla Adventures. In this video, we are going to burst the myth about work done by magnetic field. We will discuss in detail that whether magnetic field can do the work or not. Let us consider a loop which is connected with a battery of EMF E, and some current is flowing in this loop, and this loop is attached with some mass m. Loop is itself massless, but some mass m is attached at the bottom of the loop. Now this loop is in equilibrium. So in equilibrium, this force acting on the loop, let us first of all discuss the direction of the force. You can see that the force acting on the upper part of this wire will be in upward direction, and the force acting on the lower part will be in downward direction. So the net force will be 0. But let us erase this magnetic field and let us assume that magnetic field is partial, which means that magnetic field is acting on only this part of the loop, not on this part. So this force F1 will be balancing out mg, or F is balancing out mg, and the force acting on this part of the wire will be in this direction, and the force acting on this part will be in this direction. So they will be cancelled out, and the net force acting on the loop will be in the upward direction, and it would be balancing out mg. Now you can see that if let us suppose that the length of this side is A and the length of this side is B, and let us suppose that for a certain value of current I, which is equal, in which force is equal to mg, so F will be, let us suppose current is I naught, so F will be I naught into A into B, and this F is balancing out mg, so I naught is equal to mg upon AB. So this is the value of current for equilibrium. And now if let us suppose that we have induced some current which is greater than I naught, then obviously this force is larger than mg, then this loop will begin to move up. So in this situation, let us draw the loop again. Let us see that when this loop will begin to rise up and magnetic field is still partially distributed on some part of the loop, and the force acting on the loop in upward direction will be now F dash, and F dash will be greater, and now let us name it as F1. So F1 will be greater than mg, and therefore this loop will begin to rise up. Let us suppose that at any instant of time the velocity of the loop in the upward direction is u. Then you can see that the power delivered by this magnetic force F1 will be F1 into u, and work done by F1 will be positive, which is a huge contradiction between the students, because we have already studied that magnetic force could not do the work. So it is not possible that work done by the magnetic force is positive, and it is not possible that magnetic force is delivering some power. So why this is contradicting with the fact? So let us discuss this fact in detail. Let us again draw this loop, and let us see that on microscopic level what are the forces acting on the loop. First of all, let us see that electrons will be moving in this direction, and these are electrons, and the velocity of electrons in this direction will be drift velocity. And let us suppose that there is this electron, and the velocity of loop is this u. So if we see that this electron is moving with the velocity v and u in both directions, so there will be a force acting on this electron due to the resultant velocity. So the resultant velocity of this electron will be this one, and the magnetic field is in the downward direction. So we can see that the force acting on this electron will be like that. This will be the resultant magnetic force, and you can see that this resultant magnetic force is still making an angle of 90 degree with the resultant velocity. Therefore the power delivered by net magnetic force is 0. So we can say that F1 and F2 are one of the components of this net magnetic force, and you can see that power delivered by F1 is positive, which is F1 into U, and the power delivered by F2 is negative, minus F2 into V, and therefore the net power delivered by F resultant will be 0, which means that any component of magnetic field can deliver the power, but the net power delivered by magnetic field, magnetic force, and the net work done by magnetic force, work done by F resultant, will be always 0. So this is 100% true that this work done by F resultant will be 0. Now let us also discuss that where is the energy coming for work done by F1, why this F1 is doing the work. So let us see that this battery is maintaining, the battery was here and the EMF of the battery was E. So we know that this battery is, when we are increasing the current, this battery is doing the work against this F2, because this battery is applying the force F in this direction, which is equal and opposite to F2 to maintain the same value of current. Okay, so the work done by battery in increasing the current, is equal to F into V, and F is obviously equal to minus of F2, because they are equal in magnitude and opposite in direction, because we are assuming that when current flows through the wire, the drift velocity remains constant. So if electrons are moving with the constant velocity, we can say that the net force acting on them is 0. So what we can say that this work done by the battery, is equal to the work done by F1, because we have already discussed the fact work done by F1, because we have already discussed that work done by battery will be equal and opposite to the work done by F2, and work done by F2 will be equal and opposite to work done by F1. So we can say that work done by the battery is equal to the work done by F1. So what we can say that this force F1 is doing work due to the fact that battery is supplying the energy to it. So this is actually work done is the work done of the battery is being transferred to the work done by F1. Actually this is the fact. So the net magnetic force, the conclusion which we are obtaining from this topic is the net magnetic force does not do any work done on any charge, and it always acts perpendicular to the resultant velocity. The power delivered by the magnetic force is 0, and one of the component of the magnetic force can do the work. That also the work done by that component is also fulfilled by by the energy provided by the battery or source. And this is absolutely similar to the fact that let us suppose we have kept a block on this inclined plane, and normal is acting in this direction. There is no friction. Mg is acting in this direction, and F is acting in this direction. F is the external force. So you can see that this block will be moving in upward direction. Actually, this will be moving in upward direction along the incline, but one of the component of its displacement will be along y-axis also. And this force is horizontal, so we can say that the work done by this force in y will be 0, and the work done by mg in y will be negative. So which force is taking this block in upward direction will be component of n, which is, if this angle is theta and this angle is theta, so this will be n cos theta. So we can say that the work done by n cos theta will be n cos theta into y. But we know that normal reaction always acts perpendicular to the contact surface, and displacement always is along the contact surface. So it is not possible that normal reaction does any work done. So what we can say, that one of the component of normal reaction is doing the work n cos theta into y, and that energy for doing the work is being provided by the external force F. So actually the work done by F is being transferred in y direction to the n cos theta. The same thing is happening here, that work done by the battery, which is applying a horizontal force on the electron, is being transferred to the work done by F1. And F1 is not the net magnetic force, it is only a component of magnetic force. So this was the concept, and you can always conclude that magnetic force will not do any work done at all in any case. The net work done by the magnetic force will be 0 always, because it acts in the perpendicular direction of the velocity and displacement. Okay, so that was it in this video, and in the next video we are going to discuss the torque acting on a current carrying loop. Thank you.